All right, the next one here is the binomial theorem. I love the binomial theorem. It helps us multiply easier. I actually like using the binomial theorem more than the polynomial identities, and I'm going to show you why right now. So binomial theorem helps us give us a faster way to multiply. Now, specifically binomial, see the two terms to an exponent. So if we were to do 2x minus 3, and I asked you to do this right now, you would do the box method. Most of you would do the box method 3 times. So when you do your first box, 2x minus 3 times 2x minus 3. That one's a little bit easier, right? So we get 4x squared minus 6x minus 6x plus 9, right? Well, that's just twice. We need it 4 times. So now we're going to go to a bigger one. And so we have this 2x minus 3, but now we're going to multiply it by what we got here, which was 4x squared minus 12x plus 9. And then you do your box again. I'm not going to take too much time out in doing it, but then that was only to the third, right? So we would have to do it yet again. What we got, or what I got from the box here, would have been 8x cubed minus 36x squared plus 54x minus 27. And then you would do it here. Let's add that on there. Okay. Resulting in the actual polynomial of 16x cubed minus 96x. This x to the fourth, not x cubed, sorry. There we go. Cubed plus 216 x squared minus 216 x plus 81. Now, yeah, we can multiply. We're going to make tons of little mistakes along the way. But the other thing is, it takes a lot of time. So is there an easy way to do it? There actually is. And what we're going to do to help us with this binomial theorem is we're going to use what's called Pascal's triangle. So right here is the Pascal's triangle. Okay, I want to see right now, take a moment to see if you can see any patterns that would actually help us make the next 3 rows. So pause the video right now, see if you can come up with the patterns for it. All right, hopefully you come up with something. If you guys look, I can connect to the numbers and they add to the one down below. You guys see this? So on and so forth. So if I was going to give the next row, we start with 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Then we have our 1. So that would be our next row. And we could keep going and going and going. Excuse me. Now, how does that help us? Well, we're talking about the exponent, right? To the nth power. Well, 1 here is when the exponent equals 0. That makes sense because anything to the 0 is always the value of 1. Where if we said the binomial to the first, there, binomial to the second, the third, the fourth, the fifth, so on and so on. This is, so the Pascal's triangle helps us with the exponent and the coefficient in front. Well, what does that mean? Okay, this helps us with our rows. I want to make sure this is not, oh, it is the same problem, right? Okay, So what we're going to do now is we're actually going to use this Pascal's triangle to help us with the binomial theorem. We're going to do this faster, okay? Now, so here's how to do it. First of all, we need to identify what row we're using. Well, in our problem above, 2x minus 3 to the fourth, so we're using n equals 4 row, okay? Then we're going to identify our a and b. We're going to pre-write our coefficients for the Pascal's triangle, and then I'm going to show you the pattern, okay? So our A and our B, our A here is 2x, and what I always want you to do is make sure that we change this to an A plus B. So if I change that to an addition right there, that means that B is going to be -3. You guys see that? Okay, we're using our fourth row. So I always do the coefficients and leave some line up. So I have 1, 4, 6, 4, and 1. Okay, I got that from the Pascal's triangle, that fourth row, fifth row technically, n equals 4. Okay, now what do? We're going to take our A's first. We're going to start with our A and put it to the highest exponent, which of course in this case is 4. Then every time I'm going to go down 1. So now it's to the third, to the squared, to the first. And then I'm going to write this here, but eventually you guys will catch on not to have to write it, because anything to the 0 is always the value of 1. We're going to do the same thing with our B's, but in this case, we're going to start with 0 and go up. Squared. Now, as I write this, do you guys see another pattern that could help you if you made a mistake somewhere in this? All the exponents added together. So 4 plus 0, 3 plus 1, 2 plus 2, 1 plus 3, 0 plus 4. They all equal the exponent of what we're trying to expand this to. And now what we have to do is use our calculator to help us, okay? I don't have mine, so go with me. So this is 1 times 2 to the fourth times -3 to the 0. -3 to the 0 is 1. So 2 to the fourth is 16. And I see that I have x to the fourth. That's our first term. And what do you know on the other page? It was our first term, excuse me. This is 4 times 2 cubed, which is 8. -3 to the first is -3. So 8 times 4, right? 8 times 4 is 32. And 32 times -3 is 96. -96. And what do you know? That was our second term. And here we have x cubed. Next one, 6 times 2 squared is 4, times -3 squared is 9. And what do you know? You get 216. And this give me x squared. And as we go along, you end up with what we did before. So now you can either take your time doing all your boxes, or you can use Pascal's triangle and the binomial theorem to help us expand faster. All right, let's try one more time. Okay, we're doing the fifth. Okay, so make sure you do end of the fifth for your Pascal's triangle. So I get 1, 5, 10, 10, 5, and 1. I'm probably going to run out of room. My A in this case is 3x, and my b is negative 2y, right? Because I want it to be addition in here. That would make our b negative. So I'm going to start with my a's. I start with the highest exponent, which I know in this case is 5. And I'm going to go down each time. So 3x to the 4th, 3x to the 3rd, 3x squared. Oops, I should put that on the outside so I remember to square that 3. 3x to the 1st, and 3x to the 0. Again, that being 1, right? My b term, start with 0. Go to, now I'm at 2. Luckily, you guys will have your calculators with you because I'm going to take some time. To the 5th. All right, to have it set up. Now, what I would like to do is get a calculator. So I'm going to pause this. Won't see much for you, but I'll be right back with my calculator so I can then also show you how to plug it into a calculator. Got it. Okay, so what I would do in this case, and you guys, I would do your coefficient first. In this case is 1, 3 to the 5th. So you don't put your variables in there. We'll do the variables at the very end. So, and then negative 2 to the 0. Now with it being negative, you want to make sure that the negative is inside the parentheses. And I enter, so this would be 243. Now I look back at my variables. This is x to the 5th, and y to the 0 is just the value of 1, so I don't have a y. Then I'll do the next one. 5 times 3 to the 4th times negative 2, close the parenthesis, to the 1st equals. So I get negative, so it's minus 810. Now if I look at this, this is going to be x to the 4th, y to the 1st. And do it again. 10 times 3 cubed times negative 2 to the 2nd. So it's going to be a positive 1080 x cubed, and then y here is squared. Next one, 10 times 3 squared times negative 2 cubed. Negative 720. Go back to my variables, x squared, y cubed. 5 times 3 times negative 2 to the 4th. Positive 240 x to the 1st, y to the 4th. Again, I can add up all my exponents there and they should equal 5. So here I get 1 times 3 to the 0, which I know is 1, so really I didn't have to put that in there. Negative 2 to the 5th equals negative 32. Now be careful, because this is x to the 0, so there's no x, but y is to the 5th. By using the Pascal's triangle and binomial theorem, the idea behind it, this was a lot easier to do and a lot quicker than just doing my box 4 times over, right? Making tons of little mistakes. So in the last couple lessons, you learned some quick ways to do some mathematics based on patterns. Let's see how you can work with the binomial theorem.